I want to finish this lecture by presenting a synthesis of a few subtle aspects of thermodynamics. First is the assumed universality of the second law of thermodynamics. In the first part of 20th century, physics got revolutionized because of the discovery of the quantum mechanics and the theories of relativity. Virtually all laws had to be reformulated, revised. Even the first law of thermodynamics had to be amended because of the discovered mass energy equivalence principle originating from the special theory of relativity. The famous E is equal to mc squared relation derived by Albert Einstein. One law survived this onslaught, the second law of thermodynamics. The second law of thermodynamics is a generalization made from observations in engineering scale macroscopic systems. And yet, the confidence in it seems to be so great that it is confidently applied even in cosmology. And the cosmologists will talk about the change in entropy of the entire universe. The second aspect is that thermodynamics is no ordinary branch of science and engineering. It transcends into the realm of philosophy and even mysticism. Godlike pronouncements are made. For example, it is impossible to construct a perpetual motion machine of the second kind. And despite best attempts by the scientists and engineers, nobody so far has been able to build one. The human sense of past, present, and future, our sense that there is an arrow of time, seems to be inextricably linked with the direction of increasing entropy. We can comprehend certain phenomena and not others. As an example, suppose a glass vessel falls from the top of a table onto the floor and shatters into a large number of small pieces. Now imagine if any one of us sees the opposite event, that is, all these small broken pieces of glass collecting together, forming the glass vessel and jumping back to the top of the table. Such things do not happen in this universe. In the middle of this lecture, I have described that natural processes have preferred direction given by the laws of entropy. Then there is this eerie feeling about the property called entropy, which seems to be increasing all the time, prompting Max Born to ask the question, where does all this extra entropy come from? This establishes a new cosmology, the cosmology of heat, in which the universe progresses inexorably to its own heat death, at which the state of maximum entropy will be reached when all of the energy will be available. None of it will be lost, and yet none of it will remain usable. The third point I have discussed more fully in the complementary lecture I have given on understanding thermodynamics with historical perspectives, in which I have described that the development of the subject thermodynamics, in the development of the subject thermodynamics, engineering preceded science. So I contest this assertion often made that engineering is merely an application of science. In fact, the science of thermodynamics grew as a result of technological progress. My dear students and the respected audience, I hope I have been able to transmit to you the feeling of why thermodynamics is important and why it is relevant even today. I have demonstrated the dynamism of the subject. For example, this combined cycle efficiency revolution has taken place really in the last 20 years of the 20th century and in the 21st century, in a subject which grew over a few hundred years. I have explained the science, engineering, history, economics, politics, and social aspects of energy production that has happened in the past. The future is in your hand.